In this session, I'll be discussing a problem on Perceptron related to artificial neural networks chapter. Consider a Perceptron to represent the boolean function, which is an AND, with initial weights as W1 0.3, W2 is minus 0.2. The learning rate alpha is 0.2, bias is theta is 0.4. This is a diagram of the perceptron which is shown. As I have told in the previous theory, perceptron basically consists of two main things. This is a weighted sum plus the activation function. In the question, the activation function is given as a step function. So step function is f of x. The f of x will give output as binary 0 or 1, right? Because it's a step function, it will give the output as 0 or 1. And they have given in the question, if f of x is greater than 0, the output is 1. If it is less than 0, the output is 0. So this is our activation function. Design a perceptron that performs boolean function and updates the weights with until the function gives the desired output. So whatever is given in red is the question. Now let's start solving it. First write down whatever is given in the question. Okay. Perceptron here represents a boolean function and. The initial weights are W1 is 0.3, W2 is minus 0.2. The learning rate is given as alpha is equal to 0.2. Bias is theta is 0.4 and activation function is step function, that is f of x. Okay. So now first you write down the AND truth table. This is a basic AND truth table which you know. Now these are the steps you need to do while finding this problem. Is this first in each epoch, first we have to calculate the weighted sum. Then we have to compute the activation function. In the activation function, I will find out the y estimated output. Right? How do I find the estimated output is? It's given in the question. If f of x is greater than 0, output is 1, else output is 0. Then I am going to compare estimated output with the desired output. If there is a difference, that means there is an error, I have to update the weights. The activation function formula is, it's a step function, right? So step of x1 w1 plus x2 w2 minus theta. x1, x2 are the inputs to the boolean function. W1, W2 are the weights. Theta is the bias value. Okay. And we have to calculate the error. Error is E of t is equal to desired output minus the estimated output. If I get the error as positive, then we are going to increase the perceptron output y. If I get the error as negative, I am going to decrease the perceptron output y. So how do you update the weights is delta wi is equal to alpha into E of t into x of I into xi, and then after you find the change or the delta value, add it to the existing wi. So wi is equal to wi plus delta wi. So let's begin the problem. So this is the first epoch and this is my first table. So in the table, first you write off the inputs. These are the inputs to our boolean function x1, x2. This is the desired output. Okay, that is y desired. Then this is the estimated output, y estimated, error, w1, w2. These two will be the updated weights and this is the status. First, these three columns you can fill easily. Okay, so these are all the different combinations. What is the desired output of an AND gate? When the input is 0, 0, it is 0, 0, 1, it is 0, 1, 0, 1, 0. When all the inputs are 1, then it is 1. This is basically nothing but our AND truth table. Now I have to find the estimated output. How do you find the estimated output? Nothing but you have to compute our activation function, the formula which I just showed here. Right? So step of x1 into w1 plus x2 into w2 minus theta. What is x1 here? 0. x2 is again 0. What is w1? 0.3. w2 is minus 0.2. This is the initial weights which is given in the question. Minus theta. What is theta? It's given in the question as 0.4. Okay. So when I compute this, how much do I get? 0 minus 0.4, I get minus 0.4. So since it is less than 0, the output is 0. This I have given in the question, right? Step function. Step function, if f of x is less than 0, output is 0. If f of x is greater than equal to 0, output is 1. Since this is less than 0, make it as 0. Now you compute the error. What is error? Desired error minus the estimated error. Desired error is 0, estimated error is 0. So 0 minus 0 is 0. Since the error is 0, write the status as no change. No change means I am not going to change the weights. Retain the previous weights. Previous weight of W1 is 0.3. Previous weight of W2 is minus 0.2. Keep it as it is. Now come to the next input, 0, 1. What is the desired output? 0. This one is step of 0 into W1 plus 1 into W2 minus theta. W1 is 0.1 only, right? There is no change. W2 is minus 0.2. So what did I get here? Minus 0.6 It is again less than 0, so I am getting 0. What is error? 0 minus 0 is 0. So again there is no change. Write the same weights as it is. Now come to the third one, 1 0. Step of 1 into W1 plus 0 into W2 minus 0.4. So I am getting the value as minus 0.1. Again it is less than 0. So output is 0. So therefore I write the error as 0 minus 0, that is 0. Again since error is 0, there is no change. Write the weights as it is, the same one, 0.3 minus 0.2. Now coming to the last one, 1 1. Desired output is 1. Find the estimated output. Step of 1 into W1 plus 1 into W2. So that is 1 into 0.3 plus 1 into minus 0.2 minus 0.4. So how much do I get here? 0.3 minus 0.2 is 0.1. 0.1 minus 0.4 is minus 0.3. Again it is less than 0. Write it as 0 only. Now what is the error? Error is desired y minus estimated y. So here it is 1. So 1 minus 0 I am getting as 1. Now since the error is 1, there is going to be a change. What did I say? If error is positive, I have to increase the perceptron output. So now let's see how I can compute the weights. Okay. So write down for the input 1 comma 1, the weights are updated as, this is a common formula. Okay. So delta, what was the formula which I just showed you? The updation of weights is delta Wi is equal to alpha into error into xi. Then Wi is equal to Wi plus delta Wi. The same thing I am doing here. Delta W1, here I is 1. I will do for the first input. Alpha into E of t into x1. Instead of I, write here 1, 1. What is alpha? The learning rate is given in the question as 0.2. What is the error? Error E of t. Error E of t, what did we get in the for this input? 1. For this error, I have to compute this. Okay. So error is 1 into, what is the input? 1, because my inputs for 1. So I am getting delta W1 as 0.2. Now W1 is equal to W1 plus delta W1. What is the initial W1 I had? The previous W1, 0.3. To that you had 0.2. So this is my updated weight. Similarly, do for delta W2. Delta W2 is equal to alpha into ET into x2. Alpha is 0.2. Error is 1. x2 is 1. So I am getting 0.2. Now W2 is W2 plus delta W2. What is the previous weight? Minus 0.2. To that I am adding this delta W2. So I am getting 0. So now I am going to update the table 1 for this input. So I am going to update W1 as 0.5, W2 as 0. So that's what is done here. Okay. Now we have to go for the next epoch, because there is a change, right? Until there is no change, I have to keep updating the table. Because there is a change in the last row, I have to go for the next epoch, epoch 2. Same thing, x1, x2, y desired. This will remain the same. Y estimated. Now the same concept remains the same. So step of, right, 0 into W1. What is a W1? I have to now take this. This is the updated weight. Okay, I have to take this, not the initial one which was given in the question. So 0 into W1 plus 0 into W2. W2 is 0 minus 0.4. So what is I am getting? Minus 0.4. It is less than 0. That means output is 0. What is the error? 0 minus 0, that is 0. Because there is no change, error is 0, there is no change. I am going to retain W1 as 0.4, W2 as 0. There is no change. Now coming to the next one. Step of 0 into W1 plus 1 into W2 minus 0.4. What did I get now? It is 0 minus 0.4. Again I am getting negative value, which is 0. So what is, since it is less than 0, the output is 0. So error is 0 minus 0, that is 0. Since there is no error, again no change, keep the weights as it is. Now coming to the next one. Step of 1 into W1 plus 0 into W2 minus 0.4. What is W1? 0.5. W2 is 0. So what did I get now? 0.5 minus 0.4. I am getting 0.1, which is greater than 0. So my output is now 1. Okay, now why is this? Because this is a step function. It's given in the question. If f of x is greater than or equal to 0, output is 1. So make it as 1. Okay, now what is the error? 0, because desired output minus estimated output. It's not the reverse. Keep that in mind. So 0 minus W1 minus 1. So I get minus 1 here. Now there is an error, so I have to change. The status is changed. Now I have to update the weights. Now come down immediately. Don't fill the next column, next row. Come down and calculate the update weights. Immediately you have to do it. So for the inputs 1, 0, the weights are updated as delta W1 is equal to alpha into E of t into x1. Okay, alpha is 0.2. E of t is what? What did I get? -1. Take that. Into x1 is what? 1. x1 is 1. So I'm getting -0.2. W1 is W1 plus delta W1. Previous W1 was 0.5. To that you add this updated one. 0.5 minus 0.2 is 0.3. Similarly do for W2. Delta W2 is alpha into E of t into x2. That is equal to 0.2 into error is -1, right? Which I got for this. Into x2 is 0. So I'm getting 0. Therefore W2 is, the previous W2 was 0. The change is also 0. Therefore W2 remains the same. So this is our updated weight for the input 1, 0. Now come back to the table and fill this 0.3 and 0. Now let's go to the next one. For this again repeat, step into 1 into W now 1. Now which W1? You have to take this one. Don't take the one which I had here. Take this one. So 1 into 0.3. That's why I put in red. Please take this. 1 into 0.3 plus 1 into the 0. Minus 0.4. So how much I am getting? 0.3 minus 0.4 minus 0.1 less than 0. Again it is 0. Okay. Now what is the error? 1 minus 0, 1. Again I am getting error as 1. It is positive. So that means I have to update my weight. So right here change. Again update the weights. For input 1, 1, weights are updated in the same way. Delta W1 is equal to alpha into E of t into x1. So alpha is 0.2 into error is 1 into x1 is 1. So 0.2. Add this to W1, I am getting 0.5. Similarly delta W2 alpha into E of t into x2. Alpha is 0.2, error is 1, x2 is 1, 0.2 I am getting. Add that to the initial previous weight. Previous weight was 0, 0 plus 0.2, 0.2. So this is the updated weight. So now W1 you come and fill this up. 0.1 you fill it up here, 0.2 you fill it up here. Okay. Now should I go for the next epoch? Yes, I have to, because until the table does not show any, all status should become no change. Until then I have to keep doing. So now we'll go for epoch 3. Similarly, you would calculate this. Okay, the first 3 columns you know it. Y estimated, what value of W1, W2 I have to take now for the calculation? This one, 0.5, 0.2. So see 0.5, 0.2 I have to take. 0 into 0.5 plus 0 into 0.2 minus 0.4. So I am getting 0 here. Error is 0. So there is no change. So the weights are 0.5 and 0.2. Again do it for the next one. 0 into 0.5 plus 1 into 0.2 minus 0.4. I am getting minus 0.2 less than 0, 0, 0 minus 0, 0. Again there is no change. Weights remains as it is. Now for the third one. What do I get? 1 into 0.5 plus 0 into 0.2 minus 0.4. I am getting a positive value 1. So that means error what I am getting is 0 minus 1. I am getting a negative value. So that means I have to change my weight. Actually it should, output should actually decrease. So now come here, find out what should be the updated weights. So for write down for input 1, 0, the weights are updated as delta W1 is equal to alpha into E of t into x1. Right, alpha is 0.2, error is what? Minus 1, this one, minus 1 into x1 is 1. So I am getting minus 0.2, therefore W1 is delta W1 plus W1 minus 0.2 plus 0.5, I am getting 0.3. Similarly, find out delta W2, alpha into E of t into x2, 0.2 into minus 1, x2 is 0, this one. So I am getting W2 as 0.2. So this is the updated weight. I have to go back and fill it here, 0.3, 0.2. Now come to the next step. Again find out step 1 into 0.5. Which one? Take this value. Okay. We are supposed to take this one. 1 into 0.3. It's a mistake. I have to take this updated weights. 1 into 0.3 plus 1 into 0.2. So how much I am getting? 1 into 0.3 is 0.3 plus 0.2, 0.5. 0.5 minus 0.4 is 0.1. It is positive only. That's why it has not impacted. Okay. Which weight I have to take? This one. 1 into 0.3 plus 1 into 0.2 minus 0.4, 0.5 minus 0.4, 0.1. It's greater than 0, 1, right? So 1 minus 1 is 0. This has not affected anywhere. So the error, what is that I am getting? Error as 0. Since the error I am getting as 0, no change, no need to change. So retain the previous weights. Okay. Now Should we repeat, go for the next epoch? Yes, because there is one change in the weight here. So let's go for the fourth epoch. Similarly, I have which weights I have considering. I have to consider these weights 0.3, 0.2. So similarly, 0 into 0.3, 0 into 0.2 minus 0.4. I am getting negative 0. 0 minus 0 is 0. There is no change. Write it as it is. Now for this one, 0 into 0.3 plus 1 into minus 0.2 into minus 0.4, I am getting negative value, which is 0. 0 minus 0 is 0. Error is 0. There is no change. Now for the third one, 1 into 0.3 plus 0 into 0.2 minus 0.4. So now I am getting minus 0.1, which is less than 0. 0. 0 minus 0 is 0. Again, there is no change. Now for this one, 1 into 0.3 plus 1 into 0.2, 0.5 minus 0.4 is 0.1, which is greater than 0. 1 minus 1 is 0. Again, there is no change. Now we are done. All the status I'm getting as no change. So that means I need not update the weights anymore. So you just write this conclusion that it is observed that with 4 epochs, the perceptron learns and the weights are updated as, you can write here, W1 is equal to 0.3, W2 is equal to 0.2. This is actually your answer, which you should highlight, with which the perceptron gives us the desired output of the Boolean AND function. So that's it. Thank you so much. Any doubts, please write to me. Thank you so much.